good day and welcome back to Everything Mathematics. Today we're going to continue our series on calculating the gradient of a line under geometry. Today will be a part one of two videos because there are two different ways in which I want to show you how to calculate the gradient, but we're going to do them separately. So that's our objective for today. Today we're going to be calculating the gradient of a line given two coordinate points on the line. That will be the part one. And tomorrow, which will be our part two, we'll look at calculating the gradient of the line when given a y-intercept and a point on that same line. So, quick recap. Let's talk a little about gradient. First, the gradient is also known as a slope. That's something you need to know. So when we think about gradient, we think about a slope, an inclination, a hill. And of course, it could be in either direction. It could be a positive one, it could be a negative one. Gradient is also the general format of a linear equation is this here, y is equal to mx plus c, where m here will always represent the gradient. So your m is the gradient of any given linear equation. And last but not least, it's nice to know that when the gradient of a line is 0, it will always produce an horizontal line. And remember, a horizontal line is a line that runs from east to west. East to west, west to east. Put the cardinal points west to east, east to west. Well, it doesn't matter, but it runs this way. So once a line has a gradient of 0, that is what will take place. Now let's look at the formula to calculate the gradient when given 2 points. And it's a very simple formula. And here it is. So to calculate m, or the gradient, all we do is we take, because remember we have two coordinates. So we take the y's of the two coordinates and we find the difference between them. And then we take the x's of the two different coordinates and we find the difference. And then of course we just divide the top by the bottom and that will give us m. So let's just take a generic value. So remember we must be given 2 points. So we have x1 will correspond to y1, and of course we will have x2 which will correspond to y2. So all we do here, if we're given two different points, we can take the y's and the x's, find the differences, and then divide them by each other, and that will give us the gradient. And we'll do that in an example. Don't worry, I wouldn't do this one algebraically. Let's use an example. So here, let's practice this one. So here they're asking us to calculate the gradient of the line passing through the coordinates 0, 2, and 5, 4. It's also always nice to be able to understand this geographically, like in a sketch. So if I go to draw a quick sketch, imagine I draw my coordinates plane like this, and let's see where we could get this line and where we could get this line. So 2, 3, we could say 2 is approximately here on the x-axis, and let's put 3 up here. Because remember, just sketching here, this is our y-axis, this is our x-axis. So point 2, 3 will be, let's say, somewhere here. And 5, 4, let's say 5 on the x-axis is somewhere here. And 4, let's say, is just right above 3. So that point will be somewhere over here. So they want us to find this gradient here, basically, the gradient of this line. And for those I noticed here, the formula basically telling us that we're finding the difference in the rise, of course. How do I sketch this here? The rise over the run. That's basically what is taking place. So the rise is how much it went up, and the run is how much it went across. So if we go to use this drawing, we could clearly see that it went up 1. From 3 to 4, it went up 1. And we can clearly see that from 2 to 5, it went across 3. So the gradient here is supposed to be 1 over 3. Of course, this is graphically, just drawing it, we could see that. But the formula works out the same way. So let's use the formula and let's see what we end up getting. Well, we have to end up getting that too, but so we know that the formula is y2 minus y1 all divided by x2 minus x1. And what a straw for a lot of students sometimes do is identifying which one is y2, y1, x2, y2, x1. So I usually say pick whichever 2 points you want. Whatever you let one be, then the other one will be the opposite. So I would let here be x1, so therefore here would be y1. And it doesn't matter, as I said, which one you choose, they would work out to be the same. And as a result, here now will be x2, and here will be y2. And once I set that clear, it's just to substitute values into y2, y1, x2, and x1. So according to what I just picked there, my y2 is 4. So here I will put 4 minus my y1. Y1, look at it there, is 3. So that's my y1 over x2. Look at my x2 here. My x2 is 5 minus my x1, and my x1 here is 2. Good. And once I solve that, we could clearly see here that 4 minus 3, that's 1, over 5 minus 2, that is 3. Which is the same thing we got, of course, when we try to do it graphically through this sketch over here. So this is basically what the formula is doing. It's basically telling us that we're dividing the rise by the run. How much we went up, which is the change in y, versus how much we went across, which is of course the change in x. And you would see some formulas written like that too. So you would see in some textbooks they have, for example, m is equal to change, or they use a symbol. The symbol for change is a little kind of triangle. So change in y divided by change in x. And this is the language we also use when we're doing calculus. Change in y divided by change in x. And that's another way to find, or that's how we basically find the gradient when given 2 points. Let's do one more example. Here we have another example. Calculate the gradient of the line that passes through the coordinates 6, minus 6 and 2, and 2 and 1. And again, this time I'll do the opposite, just so that we see it doesn't matter which one you choose, as long as you label them right. So let here be x2 now. So here will be y2. And let's make here x1, and here would be y1. And again, I always like to recall a formula. Let me change the color here. Let's use what? Light blue. So we say m is equal to, just recalling the formula, y2 minus y1 divided by x2 minus x1. And since we already labeled our x's and our y's, it's just to identify which one we label as which. So y1, look at y2, I identified y2 as 4. So 4 minus y1 is 1. All divided by x2, which is minus 6. x2 is my minus 6, minus x1, which is 2. Good. And once we do that, it's just a matter of simplifying. So at the top, I have 3, and that's divided by negative 8. And yep, that's my gradient. So my m here will be 3 over negative 8, or you could say, simply put, this is negative 3/8. Good. And that's basically how we find a gradient. Of course, when given 2 points, I would say it's one of the easiest way to find a gradient. Not all the times, but most times that's the easiest way to deal with it, right? So bear that in mind, and that should bring us to the end of today's session. So as always, feel free to like, share, and subscribe. If you haven't subscribed as yet, give a comment if there's anything you're not clear about or you would like us to try another one. And turn on that notification so that you can continue getting videos on a daily basis from Monday to Friday. Of course, tomorrow we're going to look at the part 2 of this video, which will incorporate finding the gradient when given the y-intercept and a point on the line. 1 point, not 2. So until then, you take care. All the best.